Okay, now we did the simple ones, the alkanes. Okay, now we're going to move on to an alkene. And an alkene is where you've got at least one double bond. You might have more, but you have at least one double bond. Okay, so and now we're going to drop the ending. Instead of ANE, it's going to be ENE. And the other thing is, if the double bond isn't on the first carbon, you have to say where it's at. Okay, so sometimes you have an alkane with two double bonds. Okay, so you'd have to say where the two double bonds are, which carbon they're on, and then you would add diene. So like if you had a chain of 7 and you had a double bond on the second one and the third one, you'd say 2,3 heptadiene, because it would tell you there's two double bonds. If there was 3, it would be triene and so on. Okay, an alkene with numerous double bonds can be called a polyene, like polystyrene, the stuff that the coffee cups and stuff are made out of. But we're not going to get that involved. But if you see that, that's what it means. It has many double bonds. Okay. Here's, this is not a real big picture, but this is the simplest one, ethene. Okay. You have two, a double bond in between them, and these are your hydrogen or whatever, and this is just called ethene. Okay. And you can get crazy like this. See all the double bonds here? And this has other things. This is actually carotene. It's beta carotene. It's a source of vitamin A. It's one of the pigments, especially in carrots. Okay, the orange color. Okay. All right. So you can see they can be very simple. They can be very complex. All right. So one thing to remember about the double bonds, when we had single bonds, they can rotate. They're, like I said, they're like an axle, but now you're putting 2 there. So now they're stuck. They can't rotate. So they actually have, if you take 2 structures and you move what's on either side of them, they actually have different ways of naming them. They can be arranged in 2 different ways. Okay. Again, they're isomers of each other. They have the same formula, but they have different arrangements. So they're like this. Okay, again, these guys cannot rotate. If you have, this is a group, whatever this group is, it's probably like a methyl group. See how this one, they're both down, or if they were both up, it wouldn't matter. But if they're both on the same side, this would be called cis ethylene or whatever it is. This case, there's one on the bottom and one on the top, or you can have one on the top and one on the bottom. Again, as long as they're on opposite side, then they're called trans. We're not going to spend a lot of time with the cis and trans, but that's what they mean. Okay, these two are geometric isomers of each other because they can't rotate. They actually, because you have different groups in different places, they line up a little different and they have different properties. So even though their formula is the same, because these two are on the same side and these two are on opposite side, this is called cis, this is trans. So you put cis in front and then you just name them like you normally would. Okay, and again, we're not going to spend a ton of time on these, but I just wanted to show them to you so if you see them, you don't get confused. Okay, here's examples. Okay, here's ethene. Okay, it was ethane, but you had a double bond. And if it's on the first carbon, you guys don't have to put a number. If it's ethene, it has to be on the first carbon because there's only 2. Okay, so this would be ethene instead of ethane. Here's propene instead of propane. Because again, you got a double bond. And again, if it's on the first one, you can write 1 ethene or 1 propene, but you don't have to. Okay. If it's on the first one, you don't have to. But now here we have butene. Okay. But it's not on the first carbon. So we have to say where it's at. This should have a dash in there. Sorry about that, guys. So this is 2-butene. Okay. Because the double bond isn't on the first carbon. If it's on the first carbon, you don't have to write a number. You can, it's your choice, but if it isn't, you have to write a number. You have to say where it's at. Now this one, and you can't see it's diene here. Sorry, I cut it off. But here we got 2 double bonds. Okay, 1, 2 on the second, 3, 4. We have 2 of them. And it's 1, 2, 3, 4, 5. So that's penta. And then you just put pentadiene. Okay, so that tells me on the second carbon and on the 4th carbon, there's a double bond. Okay, so the name tells you everything about it. All right. So again, you just count them like you did before and change the ending to ENE. If the double bond isn't on the first one, you got to say where it's at. And if there's more than one, you got to say where they're at and use. And again, if there was another one in here, we'd use triene. Okay, so you got to say where they're at and how many there are. Okay, here's some other ones. This isn't the greatest picture. Sorry, you guys. I'm taking these off the internet, and sometimes when I copy them, they're not great. And again, because I can't draw all this stuff. I'm just not very good at that. I mean, I could hand draw it, I guess. But anyway, here we got 1, 2, 3, 4, 5, 6. This is the zigzag one, or the condensed. I'm not the condensed, but the, what do they call it? The skeletal. Sorry. Okay, on the first one. And again, you don't have to write the 1 if you don't want to, but you can. Here we have 1, 2, 3, 4, 5. We've got hexene again. The first one is a double bond. And whenever you have a double bond or a triple bond or anything, they take precedence over the numbering. They're, you know, they want the lowest numbers, so that's why I started numbering over here. And then on the fourth one, so 1, 2, 3, 4, we have a methyl group. So it'd be 4 methyl, 1 hexene. Okay. This one, we got 2 groups here. We have 2 ethyl groups because they're 2 carbons. Remember, if it's 1, it's methyl. If it's 2, it's ethyl. So here we got 1, 2, 3, 4, 5. And again, you can look at this as well. I guess I'm more of the condensed one. That works easier for me. But 1, 2, 3, 4, 5. So I know that's pentene. And the double bond's on the first one. So 1 pentene takes care of this. And then these 2 groups are on the second and the third. 2, 3 diethyl, 1 pentene. Tells you everything that's on there. Okay. And again, you can draw them this way or this way. I guess I tend to see people do this more because it's just a little easier to see. This one, sometimes people struggle with this one. Okay. And again, on this one, some people would want to start numbering down here. You want to number with the double bond. Okay. So those are some examples. Here's some more. Here's CH4. So here's butene. And again, this is 1 because it's on the first one. Here's on the second one. Okay, here we move them around. So now we got a methyl group on here. So we've got 1, 2, 3. Okay. And this on the second one, we have our methyl group. And again, if it's on the first one, oh, we're missing an L here. Sorry, you guys. I just copied these. It should be methyl propene. And you could put the 1 in there if you wanted to, but you don't have to. By saying propene with no number, then it's on the first one. And if it's not, then you messed up. Okay. Here is cyclobutane. So now it's butane. But see, they're all CH4. And again, it's to show you all the different combinations you can end up with. Okay. It could just be 4 carbon with the hydrogen around. That's cyclobutane. It's a chain. Here's a propane. But then I have a methyl group on here. And again, 1, 2, 3, 4 carbon. But my chain or my ring is right here. So that's cyclopropane. And then and again, since there's only 1, in a ring, you can start counting any way you want. You want the lowest numbers. So if you want to, you can write 1 methyl cyclopropane, or you can just write methyl. That means it's on the first one. And I don't know why they forgot the L's in here, you guys. But again, I cheated. I copied this off the internet. But you get an idea. These are isomers. They all have the same amount of carbon and hydrogen, but they're set up different, so they're named different. These are all 5 different, totally different compounds. Okay, they react differently, they have different properties, and so on. Okay, so again, alkenes and alkynes. Now an alkyne, now you have a triple bond. Okay, and so instead of ENE, like the double bond, EN and YNE. Okay, alkynes they have a linear shape around a carbon, and then you're going to have a triple bond. Here's ethyne. And again, I always think of when I do alkynes, you sound like you're from the South. Well, there's ethylene. It's actually acetylene, and any of you guys that weld, the stuff that you get in the containers. But anyway, we got a triple bond there. Okay. Here's your examples. Now this is ethyne, and I have the open and the condensed. Here's propyne, 1, 2, 3. Butyne. See how you think it sounds like you're from the South? And all of these on the first carbon. Okay, so that's why there's no number there. If I move this double bond over here, or triple bond over here, I'd have to move some of these hydrogen. But if I moved it here, then it would be 2 butyne. Or if I moved it over here, it could be 3 pentyne. So you have to say where the triple bond is. And all of these cases, they're all in the first one. So you don't have to write the number. You can, but you don't have to. And I have both the open structure, or the Lewis structure, and the condensed structure. You can see both of them. Okay. If I'm looking at these, okay, I have 1, 2, 3, 4, 5. You can go 1, 2, 3, 4, 5 this way. I mean, it's 5 no matter which way you go. Okay, you want your triple bond to be the lowest, so 1, 2. So, and then these groups, well, if it's 1, 2, 3, 4, 5, we got on the fourth one, I got 2 methyl groups, so that's why it's 4,4-dimethyl. That takes care of that. 2, and then it's a chain of 5 pentyne on the second bond. On the second carbon, I have my triple bond. Okay, over here I got 1, 2, 3, 4, 5, 6, 7, 8. Got no other groups. It's on the 1, 2, third one, so it's just 3-octyne. Okay, on the third one, I have a triple bond. Over here, it's on the first one, and then I got this methyl group. So 1, 2, 3, that's where I get the 3-methyl. And then 1, 2, 3, 4, 5, 6. I could have just put 3-methylhexyne. I put a 1 in there to show you that's on the first carbon. And again, this is optional. You can do it if you want to. You don't have to. Okay. Then I did a goofy one. Here's a double bond and a triple bond. Triple bond takes precedence. So it's 3, and it's a chain of 1, 2, 3, 4, 5, 6, 7. Okay. So what this tells me is on the third one, I have a double bond. Oh, there's supposed to be an E there, you guys. Should be heptene. And then on the first one, there's the triple bond. That's just to show you how you can do it. I'm not going to give you too many, I won't give you any like this, but I just wanted to show you there's ways of naming everything. So whenever you have a structure, you name it everything. Okay. Now I think, oh, this just reviews what I talked about already, the alkyl groups. I guess I should have moved this up. They're the substitutes. That's the methyl and the ethyl. If there's 3, it's propyl, and so on. The root name is based on the number of carbon atoms in the longest continuous chain. We already talked about that. And that's the parent chain. So I guess I'm just reviewing the rules here. Okay. And then a prefix is inserted in front of the root that indicates where the substituents is, where the substitute groups are. Okay. And we've already been doing this. So, and this again is in your book. It's just a review of how to name them. So locate and assign the root of the main chain. If the carbon-carbon double or triple bond in the if they're in there of a double or triple bond, you look for the longest continuous chain that has both those carbon atoms with the double and triple bonds. That's your longest chain. Okay, so sometimes you might have a group on there, but if it doesn't include the double or triple bond, you have to name those as a substitute group. Okay, and then if there's 2 possible main chains with the same number of carbon, choose the chain with a greater number of substituents. Okay, and again, this is just all the stuff. You will also see these rules. And again, I'm just reviewing what we already talked about. These are in your book. Okay, and again, name each substituent, like I said. If it's a methyl group, if it's an ethyl group, you have to say where it's at and put your prefix on there if there's more than one, and then use a multiplier if it appears more than once. So that's how you do the full. And again, we said this is the International Union of Chemists. They came up with a system. It's all in your book. And again, these rules, I'm just reviewing what we already talked about. So here we have 1, 2, 3, 4, 5, 6. That's hexane. On the second one, we have 2 methyl groups, so it's 2,2-dimethyl. Because there's 2 methyl groups, some people want to write ethyl. Ethyl would be 2 carbon chain, but these are 2 methyl groups, so it's 2,2-dimethyl hexane. And again, this is just reviewing what we already talked about. I think is aromatics. Okay, we'll save aromatics for next. So we're done with the next part. We're going to practice naming some alkenes and some alkynes. Okay, make sure you go through the practice problems. I give you a review, and then I also put a video in there that helps. That this lady that I've been getting them from, she's pretty good. She doesn't babble a lot. She just gets straight to the point. So again, if you're having some struggles, make sure you watch what she's doing. And that's it for this part of the lecture.